Hello, welcome to our channel, Knowledge Spread by Sir Boots, your teacher in General Mathematics. Please like, subscribe, share, and hit the notification bell. Let's begin! We are back in our YouTube channel, Knowledge Spread by Sir Boots. And this time, we are going to deal with compounding rates in more than once a year. So the first is compounding more than once a year. The definition of terms first. So we have the conversion or interest period, that is time between successive conversion of interest. We have also frequency of conversion, M, that is the number of conversion periods in 1 year. We have nominal rate, denoted as I to the M, but this is not I raised to M. It is just simply to mean that it is nominal rate of interest or annual rate of interest. We have rate J of interest for its conversion period. This is an interest, a rate of interest for its conversion period, that is J, because there are conversion periods in 1 year, because we deal with compounding rates more than once a year. And J is equal to I to the M, that is the annual rate or nominal rate, and M, that is frequency of conversion or number of conversion in a year. Okay, now the total number of conversion periods, that is N, but N means in a year there are number of conversions times T, number of years. So we have a table for nominal rates and corresponding frequencies of conversion, and interest rate for its period, so that we can really understand the definition, and the terminologies. We have here in this column the I to M, that is equal to nominal rate or annual interest rate. We have also M, that is frequency of conversion or number of conversions per year. We have J, that is interest rate per period or per conversion period, and one conversion period, year. So in the nominal rate, say for example, the nominal rate is 2% compounded annually, meaning once in a year. So I, for example, 2%, so in decimal, that is IM is equal to 0.02. Frequency of conversion in a year, there is only 1 because it is annual. And so the interest rate per conversion period, that is J, 0.02 divided by 1, that is equal to 0.02 still, and that is equal to 2%, and one conversion period in a year, in 1 year. In the second row, still we use the 2% as our nominal rate, compounded semi-annually. Semi-annually means 6 months. And I to the M is equal to 0.02, and the frequency of conversion in is 2 in a year because it is semi-annually. And so the rate per conversion period is 0.02 divided by 2 because there are 2 conversions in 1 year. So 0.02 is equal to 0.02 divided by 2 equals 0.01 equals 1%. And there is 1 conversion period in 6 months. So in a year, there are 6 months. So there are 2. The frequency of conversion is 2. The next row is 2. And still, the nominal rate is 2% compounded quarterly. Quarterly means there is a compounding period in 3 months. And quarter, there are 4 quarters in a year. So we have the annual rate is 2% compounded quarterly. That is I to the M is equal to quarterly means that is I to the 3, meaning 3 months in conversion, in every conversion period. So 0.02, and so there are 4 conversions in a year because there are 3 months in a year. So in the interest rate per conversion period, we have to divide the nominal rate divided by 4. That's equal to 0.005, or that is 0.5%, or there is 1 conversion period in 3 months. Okay, the next is 2% compounded monthly. So I to the 12, because there are 12 months. There are this is I raised to the 12 ni, it's not 13. So I to the 12 means compounded monthly because there are 12 months in a year. So equals 0.02, and the frequency of conversion per year is 12 because that is monthly. And so the interest rate per conversion period, that is J, is equal to 0.02 divided by 12. And the answer here is 0.0016. And a lot more decimals. That is equal to 0.16%. And there is 1 conversion period in 1 month. The next is 2% compounded daily. So I to the 365, meaning there are 365 conversion periods in 1 year. So that is equal to 0.0202. Now you have 365 conversion in 1 year. So we have 0.02 divided by 365 as our J, or interest rate per period, and the number of conversion, 1 conversion per period in each day. Okay. So the compounding. So we will go to the formula. The formula is still based on the formula for the conversion compounded, the formula for the interest rate compounding in a year. So it is still based there. So F is equals to P times 1 plus R raised to T. And here, R is splitted to nominal rate, I raised to M. And this is J. Nominal rate is, this is annual rate. And this is J is interest rate in a period. Rate per period. Say for example, the compounding is semi-annually. So, in every 6 months, there is a J or interest rate per period. So that, and J is obtained by IM over M. That this IM is, as I said, the annual rate, and this M is frequency of conversion per year. How many times the rate is compounded. Frequency of conversion. So that the final formula for the rates of interest compounding more than once in a year is 1 plus I raised to M over M close parenthesis raised to M times T. So how many years it will be? So times the number of periods per year. The number of compounding periods per year. That is M. So, we will use that formula in finding the unknown quantity in the interest rates compounding more than once a year. Say for example number 1. Find the maturity value. Find the maturity value and interest. If 10,000 pesos is deposited in a bank that pays 2% compounded quarterly. In 5 years. Okay. Find the maturity value and interest if 10,000 is deposited in a bank that pays 2% compounded quarterly in 5 years. Okay. So the formula is first layout, the given. We have P is equals to 10,000. Our R is, or IM, nominal rate. No more R now. So IM is equals to 2%. And RM is, since quarterly, 4. 4. Because per quarter is 3 months. There are 12 months in a year, so 12 divided by 3 is 4. And our T is equals to 5. So using the formula, we have F is equals to 10,000, that is for P. That is 1 plus 0.02. This is 0.02 divided by 4, because quarterly is 4, raised to 4 times 5, because there are 4 conversion periods in 1 year, so 4. Since we are talking of a quarter, 4 times 5. So we have here F is equal to this is 10,000 times 1 plus 0.02 divided by 4 raised to 20. Where does the 20 come from? That is 4 number of frequency per number of periods, frequency of conversion per year. 4, that is quarterly, times 5 years. Okay. So after that, you just use the calculator to solve. So input 10,000 open parentheses is 1 plus since it is 0.02 divided by 4, you have to enclose that in parentheses also. We have 0.02 divided by 4 close parentheses, that is for 0.02 divided by 4 close parentheses. This is for 0.02 divided by 4, this quantity. So we still have another close parentheses raised to 20. So equals. So we have 11,048.955. So F is equals to 11,048.955. So rounding it up to hundredths digit, so that is 0.96. 0.96. Okay. So, that is how to get the maturity value of the rates compounding more than once a year. So, that is it. Okay. So that it will be clearer. Rates compounding more than once a year. So, in the next video, I will also introduce how to find the present value or the principal in the rates compounding the compounding more than once a year. Thank you very much. Bye.